Hello everyone, my name's Jay, and today we'll be working through a problem that ties together the ideal gas law with the concept of writing scientific equations. So the question states that a mole of any given gas has a known weight called the molecular mass, and we are asked to rewrite the ideal gas law to include molecular mass. So we're going to start by highlighting some of the relevant information. We know that a mole of any given gas has its known weight, the molecular mass, and we know that the question is asking us to rewrite the ideal gas law, which we learned in lecture, to include this term or the molecular mass. So we'll start by writing the ideal gas law as we learned it, which states that pressure times volume of an ideal gas, or PV, is equal to the number of moles of that ideal gas times the gas constant times the absolute temperature. So we're looking at this equation now, and we know that the other piece of information that we're going to use is the molecular mass. This we will state as big M sub little m, or standing for molecular mass, and we know that the molecular mass has units of grams per mole. So immediately by looking at the two pieces of information that the question gave us, we should start to see that there is an entry point to include the molecular mass into the ideal gas law. As we can see, the molecular mass has units grams per mole, and the ideal gas law has a term for moles, which is N. So that similarity in units allows us to include the molecular mass, though we're going to need some manipulation, especially because the N is equal to moles in terms of units. So what can we do with the molecular mass, and how do those units cancel? The moles times grams per mole allows us to receive just grams. What this allows us to do is to determine that the grams and the molecular mass can be used to work backwards in order to determine the number of moles of that gas. So grams, which are a unit of mass, times the reciprocal of the molecular mass, which is going to be moles over grams. Those grams terms cancel out, the mass terms cancel out, leaving us just with moles, which is extremely useful because we know that our N term is in moles in the ideal gas law. So we see the moles per gram unit, and we should immediately identify that this is 1 over our molecular mass, which is the quantity given in the question that we need to substitute into the ideal gas law. So based on this, we know that we can substitute molecular mass into the ideal gas law simply by multiplying the reciprocal of molecular mass by the mass of the sample, and this should give us the number of moles of the sample. So we have only had to manipulate the N term, so the pressure times volume term stays the same. And now here's what we modified. We know that the mass of the sample times the reciprocal of molecular mass will give us the moles term, which we substitute out. And then we keep the gas constant and absolute temperature the same. So our final equation will be PV equals M times the reciprocal of the molecular mass times the gas constant times absolute temperature. Thank you so much for watching, and I hope this video helped in solving the problem.